Hello, College Algebra, and welcome to 2.5 Transformations of Functions. So, transformations can be described in mostly two ways, whether it's on the outside of the function, such as plus c or times c on the outside. That is always vertical, or whether it's on the inside, like minus c or times c on the inside, that would be horizontal, and it's kind of almost always, I think of it as being backwards. So let's take a look at some transformations here quick. So a shift is whenever you're adding or subtracting. Vertical is on the outside, like I said, and x as expected. So plus 4 naturally goes up 4. If I had x squared minus 4, that would go down 4. And horizontal is kind of backwards. So minus 4 actually shifts to the right 4. Or if I had x plus 4 quantity squared, that would go to the left. Now, a reflection just means I'm multiplying by -1. So vertical, it's on the outside, and you're reflecting across the x-axis. Horizontal is on the inside, right there, and you actually reflect across the y-axis. Stretch and shrink just means I'm multiplying by some term. For the sake of clarity, I'm going to go with the term a. For vertical, it's multiplying on the outside, so it'll be a stretch if a is bigger than 1. So as you see, we get multiplying by 3, so it's a stretch factor of 3. If a is between 0 and 1, that is a shrink, such as 1/3. If you want to think about it, this vertical stretch and shrink thing is kind of the same idea as messing with the slope of the equation. So bigger number increases more drastically vertically. It's also important to note I say 0 to 1 because if it was 0, it'd be simple. If it was 1, it would stay the same. And if it was anything less than 0, it would, of course, be a reflection. We wouldn't worry about that too much. And the horizontal is same idea, multiplying on the outside. It's backwards though. So if it's a 1/3 on the inside, that's a horizontal stretch by a factor of 3. And if it's a 3, it's a horizontal shrink by a factor of 1/3. A horizontal stretch and a vertical shrink look very similar and act very similar, just to some different extent. Okay. Identify the basic function, number of transformations, and which transformations. So looking at this, I would say that the basic version of this function is probably something like the absolute value function. So looking at this function, I would say that there are 3 changes. First one, of course, is we have this multiplying by 3. So I'd say it's a vertical stretch by a factor of 3. We have the minus 4 on the inside, so I'd say that is a right 4. And then I have a plus 2 on the outside, so I'd say that shifts the whole graph up 2. So if I were to graph these, g of x over here, the absolute value function, looks something like this. With the absolute value function, if I were to graph f of x right here, we would go to the right 4 and up 2, so my vertex would actually be somewhere like this, and that vertical stretch means I would grow a lot more rapidly, so I'd be a lot more narrow. Next one, f of x equals -3 to the power of x plus 2. I'd say that this original would be 3 to the power of x, just an exponential function. We, of course, have a negative on the outside, so it's going to be a reflection across the x-axis. We also have this plus 2. Now this plus 2 is inside the exponent, so I would say this is a horizontal shift, and I would say that means we are going to go left 2 units. So if I were to graph these, this one looks something like this. We would in this graph, shift everything to the left a little bit, then reflect across the x-axis, reflecting it down. So I'd get something like this. Okay. This next one, we could say that the basic function is the square root of x function. So here, I would say there are actually three transformations. A lot of times students look at this and see multiplying by -4 as one thing. I'm telling you, we're going to categorize them as two separate things. First, we get a reflect on the inside, so this is across the y-axis. We get a multiplying by 4, so we get a horizontal shrink by a factor of 1/4. And we have this -3, so our graph is going to go down 3. So if I were to graph these, g of x as the square root of x function looks something to this effect. And here, I'd go down 3, so my vertex is right here. Horizontal shrink, so I'm going to grow faster. But a reflection across the y-axis, so instead of going out to the right, we're going to go out to the left. So it looks something like, I guess I should need to grow it like that, where the horizontal aspect shrinks it. Okay. Write an equation to fit the description, label each transformation. So write an absolute value function, so I need the absolute value of x, with a vertical stretch, so I'm going to multiply on the outside. It's a stretch, so any number bigger than 1, and a horizontal shift, so at the plus or minus on the inside. Okay. So something to the effect of f of x equals 2 absolute value of x minus 3. Okay. Write a cubic function, so x cubed, with a horizontal shrink. So I'm multiplying on the inside by a number bigger than 1, and a vertical reflection. So I'm multiplying by -1 on the outside. So something to the effect of f of x equals negative parentheses 3x cubed. They're horizontal shrink, so I need that number to be on the inside of my parentheses or inside of my function. Write a logarithmic function base 4, so something like log base 4 of x, with the following transformations. Vertical shift, horizontal shift, vertical shrink, horizontal stretch, vertical reflection, and horizontal reflection. So f of x equals log base 4 of x, something like that. So let's say we have a vertical shift, so up and down, so I'm going to say plus 4. A horizontal shift, so let's say -2. A vertical shrink, so I have a number out here that's less than 1, so let's say 1/3. A horizontal stretch, so a number that is smaller than 1, so 1/4. A vertical reflection, so I need a negative out front. And a horizontal reflection, I need a negative on the inside. Now, you may notice that I have an extra set of parentheses that came out of nowhere, kind of. I have these parentheses right here. These are actually really important. You cannot write 1/4 x minus 2 and tell me this is going to the right 2. You can't. That's not how it works. Because if I go back to horizontal translations, it says plus or minus inside the function, but it has to be subtracted or added directly from x. If I do it like this, I'm not subtracting from x, I'm subtracting from 1/4 of x. So what we do there is, if we have some extra stuff in there, such as 2x minus 8, we would factor out the 2. So I get 2x minus 4 on the inside. So I would say it's a shift to the right 4 units, because that's what I'm subtracting from x. And then the 2 still stays the same. That's probably the most common mistake that I see when doing transformations. Lastly, order of transformations. You always do the horizontal translations, which is the adding and subtracting on the inside first. Then you can do all these together in any order because those are all your multiplications, which should make sense. Last but not least, you add and subtract on the outside. So why does that make sense? Well, if I was given some sort of function, for example, f of x equals negative 2 times 4 times negative 3, or sorry, x minus 3 squared plus 1. What would you do first if you're given x equals 1 besides plug it in? Well, you would do this x. I actually don't. Let's say that squared isn't there. You would do the 1 minus 3 right away. You would do the horizontal translation, the adding and subtracting on the inside. Then you'd multiply, then you'd multiply, then you'd add. So functionally, all you're doing is doing the order of operations. So in this case, you would do the shift 4 first. And then you would do the multiplication, the multiplication, the multiplication, the multiplication. All that happens right here. The order technically doesn't matter because order doesn't matter in multiplication. And then you would do this part last. So let's take a look at that in practice. For the sake of this, let's just focus on this coordinate right here. If I was given this function, the very first thing I would do is minus 3. Well, minus 3 is to the right 3. So, which coordinate is that actually affecting? If I'm talking about the left and right, that's affecting my x-coordinate. And if I'm moving to the right 3, that's essentially x plus 3. Then I would get to my multiplying. Well, that's vertical. So I'm actually doing my y value times 2 there. So I get 1 times 2, which is 2. And then last but not least, I have the down 1 right here. So that's actually, again, affecting my y value. So I get 2 to 1. Thank you for listening, and I hope you have a great day.